Hey everybody, this is Larry. This is me going with Q2 of the weekly contest 324. Smallest value after replacing with sum of prime factors. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, not gonna lie, I initially have trouble, I had trouble kind of proving the bounds. The bounds are kind of tricky with these problems and I was just struggling with it. But actually it's not that bad because I think given second thought, and this is during the contest, because the way that I thought about it initially was that I need to use the sieve, right? The famous sieve, when you see prime factors, it's always in the back of your mind, and you could do stuff in n log n and stuff like this, right? Where n is the number. But instead, I just kind of did it more brute force way. And the reason why I thought about it is that, the sum of the prime factors, and really, given that n is 10 to the fifth, the most, like, what is it? Like, let's say 2 to the 20, right? 2 to the 20 is a million, so it's even bigger than that. That has 20 prime numbers, 22s, which is 40, right? You could probably construct a max sum of prime factors that are bigger, but not by that much, I imagine, right? Like maybe, I don't know, like 17 cube or something like this, right? It's 51. I don't know if that's... but it's not going to be that much is what I'm saying, right? Like even 17 cube is 5,000, so that's actually, so maybe like, so the first iteration, my point is that it'll go down to like, I don't know, a number that is like 100 or even 200, right? But then now you're doing 200, and that number is just really easy to go down. So my point is that it only takes a few iterations to dwindle down, and so it's going to be dominated by the first operation, which is if you do the square root algorithm of just checking all the factors before the square root of n, and then making sure that they're prime, then that should be good enough. Yeah, and then you just iterate for it. The only thing that I had, the only number, and this is my algorithm, I'll go over the bad case in a second, but this is just very standard prime factorization if you're not super necessary about the thing. And because c will go up to n, or n the square root of n, this loop is O of n, the square root of n, which given 10 to the fifth, it's going to be like 10 to the third, say, right? I mean, it's less than that, but 1,000, right? So that's going to be fast. And if you even if you iterate like, I don't know, 100 times, 1,000 is going to be 100,000, right? So I'm just making up numbers, to be honest, but I'm just trying to gauge like, like very pessimistic upper bounds on how many operations. The only thing that tripped this thing up is the number 4, and that's where I got the wrong answer. People who got that with a wrong answer is very smart. And honestly, I feel a little cheating here in the sense that if I were not giving the wrong answer, it might take me a while to figure out. So I definitely save some time by knowing that 4 is the magical case. So you could say maybe it's worth the 5 minutes, or at least it's worth 3 or 4 minutes of those 5 minutes, because I don't know, coming up with that is not easy for me. But basically, if you look at 4, then it's just, the sum of all the prime factors of 4 is 4, and then that's basically it. I just return 4 because 4 is the bigger number. I actually wrote it in a way that if you go higher, maybe, I don't know, but I don't know that that's possible other than 4, so maybe this is a really weird looking one case. I don't have a great complex analysis here, and you could kind of maybe prove by exhaustion, meaning just try it for every number to see how many iteration is probably the way that I would recommend it. But like I said, but like, I don't know, I mean, I'm just making up numbers, but what's 20 to the 4? 20 to the 4 is 160,000, and that sums up to 80, right? So if you go to 80 after one loop or something like this, you're probably doing pretty okay, because now the next loop is just going to be square root of 80, and then, like I said, as long as you take care of 4, it's okay. If you ask me, I'm not really proud of this code, so don't really, try to learn from it. Remember that this is my contest code, so yeah. I think if I were to do it a little bit differently, I would actually just run this for like I don't know, 100 cycles or something, or maybe 200. Maybe I'll have to figure out the math, because then I wouldn't run into the issue with 4. I just take like the min of all the, of 200 series or something like that, right? And maybe that'll be good enough if I could do it again, just to have something that's a little bit less proofy. But just to get rid of the infinite loop. But yeah, let me know what you think. Let me know how you did it in the comments. That's all I have for this one though, so let me know what you think. And you could watch me solve it live with the mistake in the contest now. Thank you. I don't know what I'm thinking of. Maybe I do need time. So replacing sum of prime factors. Okay. So replace n with 3 plus 5. Okay. 8. Okay. I guess so. This is kind of weird. Don't know that I can prove this, but okay, let's go. Let's just try. Yeah, okay. If n is prime, then yeah, okay. I don't know if naive is fast enough, or do I have to do the table? Yeah, kind of want to do the table, but fine. If it times out, I made some mistakes here. I forgot to. That's not good. It's because C is 5. Maybe? Oh, wait. But then this would never be true, so... 7 and 3, what? So 8 and then 7. 8. Oh. This is such a mess. I don't even know if this is right. It's going to give me a wrong answer or time limit exceeded. Should have done it the other way. To dynamic programming. Really? 4? Maybe not. Maybe I'm just dumb. 4 replaces with... Oh, I see. Huh. Okay. Wow, this is hard. If... Okay. If b is greater than n... If b is greater than t, then no, that's fine. T is greater than b, then we got bigger. So that's return P. Wow, this is yikes today. Oh, oops. Okay, so that was a yikes, but probably a lot of people made it. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and how you do on these problems and so forth. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.